So, as you can tell, as I said yesterday, I'm actually doing all these lectures in Jupyter Notebook, right? And I have you guys basically set up your computer and download Jupyter Notebook. So is everyone able to at least print hello to yourself? Anyone not able to do that? Okay, great. Because today, after I stop jabbering on about notebooks, then we're going to work together and you're going to write the first section of your notebook so that we can actually kind of, do it together. So you would get some immediate feedback. It's like, oh, what you want to write about, what you don't want to write about. And that way, when you're getting ready for your first lab, you actually have that section of your notebook be ready before you even start the lab, okay? So as we said in the experimental side of the scientific method, right? You conduct some experiment, and that experiment allows you to collect data, right? And then somehow what you want to do is basically have that data into some sort of system, right? Some sort of analysis system, whether it's on a piece of paper or, in a supercomputer that, takes up, the electricity of a small country to run certain things, or, maybe just your laptop to do some fits and stuff like that. So the data, it's just some data table. This is showing some two-dimensional data table. Sometimes it's much more complicated than this, and sometimes it's not even numbers, right? It's like people's names and stuff like that. And in Python, you can read these in using this function called load text. Don't worry about these technicalities yet. But the main point of this loading this information into your code, basically your analysis, this basically allows you to parse the data. Does anyone know what parsing means? Yeah, you got the right symbol.
When you pick specific data, like
right. So maybe not every one of these columns, every data point is interesting to you. You can just pick a certain part of it. Right, you can also organize things. We're not going to talk about arrays yet today, but we'll see that. We'll do the analysis on Wednesday. You can also filter stuff. This is where all these loops and ifs and whiles and all these funky stuff that you may or may not have seen before will come into play. And this is usually the point where a lot of students get stuck because even though this thing called for loop, it looks very simple, it can get very complicated if you have like 3, 4, 5, 20-dimensional loops. It gets complicated. And then also allows you to plot. So that's why we're integrating Jupyter Notebook, where it allows you to type stuff, right, in human language. And then it allows you to type things in computer language. And that also allows you to make pictures of plots. And pictures are always nice to look at because it gives you information that otherwise you wouldn't see. We're going to teach you how to fit things using this functionality called SciPy Optimize and how to overlay the data versus your model. And then the hope is that you can actually predict something about the future, right? Things about doing science is not just about studying the past. If you want to only study the past, be a history major, and you have all the data you need. The science is also about predicting the future. Okay. And the piece between basically your analysis and result, this is where you come in. This is where you are the most important piece. This is where your brain is, right? You have to look at your data, right? In plots or fits or extrapolate or filter, whatever way you want to do it, right? And then somehow get science stuff out of it, right? And by science stuff, I mean, well, how good is your data set, right? What is the data quality? Like, what are the uncertainties? Meaning, if you measure something, how certain you are that you got the right answer, right? What kind of statistics that's required? I'm going to do as little statistics as possible. And if you were to show the statistics I show you in this class to a statistics statistician, that person will laugh at me or what I do. And just kind of get enough stuff so that we can actually get some quantities that are meaningful. Okay. And try to look for pattern in your data, right? And also the most important thing is to basically interpret physical parameters out of your data, okay? And examine how well you can actually predict the future, okay? So we're gonna start on basically on the left-hand side where we're about the data collection process. and this is where your notebook comes in. So we're going to use the little Jupyter notebook and make a separate notebook for each of your lab. In fact, you're going to make one today as an example. And these are the notebook sections that are expected. Let's make this a little bit bigger, right? Okay. You need the title, introduction, procedure, raw data. Well, usually the raw data and procedure are kind of integrated together. Okay. And you also need to do your data analysis and your results. And so what is the title? The title hopefully is pretty simple. The title have these 4 lines, okay? The lab, right? This for 102 lab 1 or whatever it is, right? And then name that experiment and name it your notebook also, because sometimes what happens is that you're going to convert this to a PDF, and you're going to have your notebook, you're going to have your data analysis and your report, and you want to know which one is which, right? Name your well, you can name yourself or whatever your parents name you, right? And then the university that you're at, okay? And all your lab partners' name. You can type out the full name or just their first initial and their last name. And then also it's very important to date things, because if you don't date things, no one knows when you did the stuff, right? Those are the 4 things. If you don't have these 4 things, I'll automatically just do a -10 on your notebook, okay? So copy and paste this and just fill in, replace the information, of course, that's in it, okay? Hopefully you're not working with Marie Curie, because actually there's only 1 R in her last name, I think. And because you'll be working with what did she poison? Radon? Is it radium that she poisoned herself with?
Yeah, I think it's radium.
Radium, yeah. So hopefully you're not working with her, okay? So that'll be bad, right? Because radiation is not good for you. And hopefully some of you guys started doing that training. I think I changed the link to that training stuff, so you should be able to access it since last week. Okay, so the next section, as I mentioned, right, is the introduction. The idea of the introduction is that this is something you type up before you come to lab, okay? This is kind of like your pre-lab situation, okay? What you want to do is kind of write up like a scientific background of the lab, and we're going to do this today because we're not going to actually do a lab on Wednesday, so we're going to do a little example pre-lab using the mass spectrometer lab, okay? And then write down what you're going to measure in this lab, okay? And then write down any uncertainties and potential errors that you could run into in this lab. What are examples of uncertainties? Well, why did I say uncertainties and error? Why are those 2 things separate? Anyone know the difference between uncertainties and errors? Robert?
Would errors be like something that I commit? Like uncertainties would be like something that you can't really.
Sort of.
Like
Sort of. So, for example, right? If I wanted to measure the length of this marker, right? I can measure it this, right? And then it's like 12 centimeters. But then this ruler only has a certain precision. Does anyone remember the difference between precision versus accuracy? Like something's very. Sorry?
It's like the how many decimal points?
What?
Like the how many decimal points are?
It's related to that, but not exactly. So there's a picture. I probably should have put this up here. That was very useful for me to think about it. Okay. Let's say you are an archer, okay? And you are shooting an arrow at a target. Well, multiple arrows actually. Okay. So let's say archer number 1 can shoot very good, and then it's like the center here all the time. But then archer number 2 hits off to the side. Okay, and then there's actually a 3rd archer. Sorry. Okay, examples of this. Okay, let's draw it over here. Okay. All right. So it's these blocks and stuff. Okay. So if you are Archer, unfortunately, the middle one is the best one, right? So this Archer is both precise and accurate. Can't spell accurate. Okay. This Archer is very accurate, but not precise. Sorry, not accurate. Sorry, the other way. Not accurate, but very precise. Okay. This Archer is actually accurate, but not precise. Some funky language wording here, right? Okay. Look at the guys on the edge, okay? So why not precise? Okay. Okay. Accurate means, right, on average, how well you're able to hit the center of the target. Okay. Precision means how often you can actually, how close you are distributed in the middle. Okay. So it's, if you are, maybe like, like a machine gun. Well, we're talking about archers, but you can shoot a lot of arrows. It's okay to be, not precise. As long as you shoot enough arrows, you're gonna hit something, right? Okay. But if you're an archer that's not accurate, but very precise, it's probably not that great because you're probably gonna like be hitting your friends instead. Right? All right. Ideally, you want to be both, but right. So basically, the thing to think about is that if you are imprecise, you're not very consistent with your shots. Okay. But if you're not accurate, you're hitting the wrong place. Okay. Ideally, you want to be both. A lot of times the experiment will not have both at the same time. Okay. And what I want to attribute is that, okay, this archer has a large uncertainty. Uncertainty. That's the difference. Okay. This archer, right, has a large error. Okay. Does that make sense? Sense now? Any questions about that? Okay. So when I say uncertainty, meaning there's a large spread in your data and then you're not being very precise of what you're measuring, right? But when you are making an error, that means you're actually measuring the wrong thing, or you're just skewed, or your entire measurement is just not well calibrated. Okay. All right. Hopefully that was okay. All right. So this is the next part is kind of like the crux of a lot of the notebook. It's the procedure part. Okay. So what you want to do when you're doing this lab, and I think since there's 9 people in here, just to give you more flexibility, in case one person is sick or something like that, instead of a group of 2, 2, 2, 3, which will make 4 groups, I think if we just do 3 groups of 3, it just makes more sense, right? And that way, if one person is sick, because typically a lot of the experiment is going to take 2 people to run. Someone has to like turning on off. The other person will be like measuring something and recording stuff. Okay. In fact, I think all the experiment takes at least 2 people to run. Okay. All right. So what we want to do is basically have one person with a computer that's going to be typing in the procedure as you do them. Okay. And make sure that whoever that person is has some sort of automatic backup. So I back up to the school has OneDrive. Do you guys have OneDrive from school? Yeah. So you can just install it, and then basically I save my all this stuff is on my OneDrive. All my class stuff is in here, right? And I think like I don't know how often it does it. It's just uploads like a new version of it like every hour or something like that. And if I make a major mistake, like I deleted a file that I didn't want to delete, I can actually just go back to the history and then recover that file. So it's actually really nice. Okay. So whoever's doing that, make sure you have some sort of good backup service, because if you don't back up your stuff and you lose your stuff, then you have to come back here and do another 3 hours of lab, right? Jupyter Notebook also has an automated save system. I don't know how often it does it. You can see that when's the last time it was saved. It was 15 minutes ago. So make sure you can also just force it to save all the time by clicking on the little disk. Okay. The clicking on that button always brings up a little funny story. Does anyone know what that symbolizes? I'm sorry? A floppy disk. Okay, some of you guys. Okay, you guys are good. Because some people, they don't even know what that is. That's just a save button to them, you know. Because they used to have these things called disks, like physical disks that are circular that you insert into your computer to save stuff. Okay. Okay, so the first thing on your procedure should always be your equipment list. So this might be stuff that are explicit in the manual. So the manual might give you like a list of stuff that you're going to use, or it could be hidden somewhere in the procedure. In the procedure, it'll tell you to use, this number 5 screwdriver in order to turn things. So you have to list that sort of stuff. The idea is that when someone reads this equipment list in your notebook, they should be able to grab everything, and if they don't have a number 5 screwdriver, right, they can order that ahead of time before they come into the lab and do it, okay? Right. So make sure you note all the equipment that's going to be used in your lab. Like, I mean, you don't have to like specify every screw, like, there's a 2x10 screw that I use to tighten this thing. But like all the kind of like equipment that has like a name, right? Your detector, your photomultiplier, your high voltage power supplies, any spectrometer, pumps, and stuff like that. All the major equipment that's not always found in like a science lab. That way, to have it ahead of time. If things have model numbers, especially if you see it on the device itself or in the lab manual, have that, and that way you can even be that specific, okay? All right, and the idea for the procedure, I'm just gonna kind of talk through this for now, and I'll show you a more detailed version of this, is to record every step of your experiment. Write down everything that you are doing, okay, to set up your equipment, not what the lab manual is typed, printed out, right? You have to write down what you are doing, not what the lab manual says. Okay, because sometimes, hopefully, right, it'll be similar, but you're gonna have to write this in your own words. Okay. Include like a schematic of the setup. I think I have an example here. Let's see, go down. Like, there's a schematic. You can include a picture of it, and I'll teach you guys how to do this sort of stuff when we go through the Markdown lesson. Okay. Record everything you measure in the lab, okay? Anything you measure in a lab, you should record, like even voltage on the multimeter. You know what those things are, don't worry about it. The size of the apparatus, if you're measuring something with a ruler, right? Put those down on your notebook. Distance between objects, basically record everything you're gonna measure in the lab, because you're gonna find that useful when you're writing your lab report. You have a container that's this size, but in the lab you guys measure how big it is, what dimensions of it, and you can calculate its volume, right? But if you didn't write that down, you have no idea how much of a volume you're talking about, and you're not going to be able to come in, do your lab report until you come in and do this, right? And then that's just gonna, it's gonna bug me, because you're gonna have to ask me to open the door to measure these things. B, you're gonna have to come in and drive over, minutes or hours or whatever, however long it takes for you guys to get here, right? Okay. If there are things that have 3 or more values, related values, right, just put them in the table, okay? And I'll teach you guys how to make tables in Markdown. Okay, any calculations you're doing to derive a quantity, do these calculations in your notebook. Don't do it on a piece of paper and throw it away, okay? The reason is that if you did a calculation in your lab and made a mistake in the lab, you will see that mistake, right? If you did it on a piece of paper, wrote down the result, right, and threw away that piece of paper, you have no way to backtrack where you make that mistake, okay? Everything you're doing in the lab is going to be typed down by some person, okay? And there's multiple ways to also like make this easier. So if you write down you do something on a piece of paper, you can take a picture of it, and I'll show you guys how to put that onto your notebook, okay? And that way, hopefully, you're fairly easy process, okay? Any data that you're going to record manually by hand, you're going to put in your notebook, okay? I'll show you how to make a table. Any data that is automatically taken, right? You're going to record the file names and where the file is stored, okay? And I have many students make this mistake where they would record data, have a list of 10 files, and then do an analysis on one of them, and then don't remember, wait, where's the data file for this came from? And there's no way for them to basically repeat that same analysis anymore because they forgot where the file is. And the file was just, with Austin or something like that. And then somehow Austin lost his thumb drive and it's just gone, okay? So if you at least write down exactly what the file name is and where you stored it, right, you will have a way to find that data, okay? Data preservation is, paramount in science because without that data, there's no way for you to trust what you did at all, okay? Okay. And the procedure basically ends after you stop taking data, okay? The procedure is up to the point where you take all of your data, okay? All right, okay. So the introduction, you can probably write by yourself, but the procedure is shared amongst the entire group of 3, right? Okay, and so that's okay. But once you stop taking data, you are going to do the data analysis individually, okay? So everyone does their own data analysis, right? Okay. You can help each other at the conceptual level. So if you're working next to each other, say, hey, how did you, make that plot? Oh, I just used this method, right? But don't share your exact analysis code with each other, okay? All right, because this is called plagiarism when you're just copy and pasting each other's work, right? And everyone, well, I don't know what net. Okay, everyone that has, the same code, right, runs the risk of basically getting a 0 in their entire lab because they're just plagiarizing off each other, okay? So you're doing your own analysis. You can talk to each other, right? You can even show each other's plots, right? And even the code itself, but don't copy and paste each other's code into each other, right? Everyone has to type in their own code and figure out their own method because everyone's going to do it slightly different, right? Okay. Okay. There's one more thing that's special for this particular method of a notebook is the using Markdown versus commenting in codes, and you're going to see an example of this as I transition from a Markdown concentrated stuff to coding. So Markdown is what I'm typing in here, right? This is basically my notebook, okay? It's used to basically discuss the conceptual part of the notebook, okay? All right, so for example, when you're loading a data set to make a plot, right, and you want to discuss, where this data set came from, what kind of plots you're making, what you're fitting to it, right? This you should put in the Markdown, not in your comment, okay? How many of you guys know what comments in code is? Does everyone not know what the commenting in code? So I'm going to show you an example. Actually, it's right here. Okay, comments in code is basically stuff you can type into your code, and the computer doesn't read it. Only you read it. Okay, and as you get more experience with this will be more clear. What is this stuff? Okay, all right. Okay, so Markdown should be written in a human language, and since we have to for this class, the particular human language you're using is English. Okay, so and you want to type this as if you're talking to your lab partner or me or one of the other professors. Okay, writing, that's your target audience. Okay, someone with a scientific background, and as if you're talking to a colleague. Okay, well, actually more accurately, as if you're writing to a colleague. Okay, not talking. Okay, all right, commenting, right, is are notes that are in the coding part, the technical and the algorithm part of your code. Okay, and hopefully you'll see this clear when we start doing analysis on Wednesday. Okay, example of this is that if you want to note what kind of cuts you're doing to your data, what variable you're looping over, how the calculation is made in the code, not in math, not in like handwriting math, right? You want that in your comment, and you want to make your comments also in the human language, but instead of talking to someone else, you're talking to yourself, okay? Especially to yourself a couple of days later, because if you don't do that, you're going to forget how you did stuff, right? Okay. All right. So how do we go from data to results? Okay. So the data analysis should explicitly show how you loaded the data, right? Even the loading process, okay, because different loading process could do different things actually. So I want to be able to replicate exactly what you did, you know, how the data is parsed, what cuts are made, what plots are made, and stuff that gives you these physics measurements and with uncertainties. And we'll talk about uncertainties probably on Monday, not this week. Okay. It's okay to use either codes or Markdown, right, to do the calculation of your uncertainties. The uncertainties is going to be this really time-taking things depending on the experiment. It's actually typically you can get to the results of your experiment, you know, with like, you know, a couple of hours of work. But then, you know, to get to the uncertainties, it's like three or 4 more hours. It actually takes more work to get to the uncertainty than to get to the central values. Okay. Okay. The end of your data analysis should be all of your results in Markdown. Okay. And make a table of it if there are more than one value with the uncertainty at the end of the data analysis section. I know there's going to be a lot of repeated information, but it's okay to repeat information because it just helps clarify where the stuff is, okay? The last section of the notebook should be a result discussion, okay? This is also done individually, okay? You can start this in parallel to the data analysis. You don't have to wait till the end. Because there may be sub results that you can get, and then you can just put that in the end, you know, in your discussion. And then as you get more results, you're just collecting more and more stuff at the end. Okay. Yeah, so most labs we're going to have multiple results or intermediate results. So that way you can just copy these results down to your discussion section. And the idea of this is that you're going to discuss whether or not these results make sense. Okay. Why do I want you to do this in your notebook versus your report? Because, right, if there's something that doesn't make sense, you want to make that measurement again, right? By the time you write your final report, it's too late to take the data again, right? I want you to catch this as you're working through the data analysis. And therefore, if you have, you know, if you're missing a data point or something doesn't make sense, you can still have time to remeasure things, okay? All right. Okay, so that's sort of the outline or the expectation, let's say, of the notebook. Okay, so every lab will have one of these, and then you're going to upload this to Canvas. Okay, is there any questions about what's expected in your notebook and how to make one? Brought some water. Okay, so now depending on how much you know about Markdown. So if you have a computer, feel free to, you know, kind of follow along if you want, just so you're not just, you know, sitting there. I've been to people who teach me coding or whatever, right? And if I'm not doing something, I'm just going to fall asleep. So feel free to do that. Okay. So this is my version of how you deal with Markdown. So you can see that this box is already labeled, is already set to be Markdown. So the first thing you know is that in Jupyter Notebook, you have the option to do code. You have the option to do Markdown. You can also have raw, right? Which basically just kind of like it's text that doesn't interpret it at all. But for this particular part, for the notebook, we want to start using Markdown. Okay. And this is sort of like a little starter guide. I'm sure if you just Google search, you know, Markdown tutorial or stuff like that, there'll be a lot of different tutorial. But I basically went through this as I'm thinking about what we need to write in the notebook, and hopefully this is all you need. So but there may be some stuff that's missing that you might need, and I'll just augment that later. Okay. Okay. So Markdown is not like your word processor. It's not exactly Microsoft Word, as you can tell, right? Because when I double click on this, you know, this just turns into what's called Markdown language. Okay, this is a separate language. And basically, the computer interprets all these little symbols I'm putting in here and then displaying it in a way that hopefully looks nice. Okay. All right, so let's go back up here. Okay. All right, so when you start your notebook, right? I think usually by default, the Python Jupyter Notebook will give you code instead, but then you want to change this to Markdown with this little Markdown drop menu. Hopefully that's not too difficult, okay? Right? So one thing to deal with is that paragraphs are a little bit different even when you're just typing stuff in English, okay? You can tell here, right? The code, when I'm typing in the code, you actually see this. You don't see this until you do, either play the box or you do a shift enter. I don't know, whichever way you prefer, they do the same thing. Okay. So you can break up your writings into separate paragraph by just having empty lines. So this is the effect. Here, let me show you what the code is, right? So if I don't have that extra line, you can see that here, right? This extra line here, right? What's it gonna do? I should not have made this so long, right? It's just gonna continue on. Okay, even though you have a carriage return in when you type in your code, okay, unless you have this extra blank line here, it's not going to give you a new line. Okay, so this is something that's kind of funky about Markdown. Okay, this is inherited from hypertext Markdown language. Okay, you can also do a BR. BR stands for break in the line. So you can actually create a break. And you can see that these two actually does different things, okay? So let's compare these two, okay? So this paragraph, right, I did a double, right? I did a double enter to push an empty line here, where on this case, I basically do a little bracket with a BR in it, right? And these two are actually doing different things, even though you would think they should be doing the same thing, okay? All right, so hopefully you guys can see the difference. Anyone wants to tell me the difference between, the double enter versus the BR function? Anyone on this side of the room? The space between? Yeah, so the double enter basically puts a empty line between things, where the BR just goes to the next line. Okay, so a lot of times you actually end up using BR, even though it takes more work actually, because double return is 2 clicks, and then BR it actually takes like 4 because you have to do a shift and then bracket stuff. So it's a lot more work, but it makes it a little bit more compact. Okay, the other thing we need to talk about before we get started are these escape command. For what the heck is an escape command? So you notice that this BR thing, right, is a special command, right? So when I go back to the code itself, right, when I type bracket BR bracket, right, this actually doesn't even show up, right, in the when you play, right? Because this is a special character, okay? And you can get rid of that by putting a little slash in front of the little alligator sign, and then a little slash in front of the alligator biting the other way sign. Okay. So this is known as an escape character. That means anything the character after this will not have a special function anymore. Okay. And this is kind of confusing when you're, especially those of you who doesn't have a lot of coding experience. Like, why are we doing this? It's like, why doesn't it just print out BR all the time? Because BR is a special functionality. Basically, the escape character, which is a slash in Markdown, makes it not special anymore. Okay, despecializes. Okay, all right. Okay, and I find that actually a lot of times I like using headers. Headers allows you to organize information into different parts. So this is kind of like, when you're writing, you have a title for your first paragraph, title for your second paragraph, that type of stuff. These headers is a simple way to make titles, separate sections, and even change the style in Markdown. So, and it's pretty easy. Actually, it's the easiest way for me to change font size also. So So if you put a little hashtag or pound sign before you start typing stuff, the more pound signs you put, the smaller it gets. Okay, so I'll show you an example where I put 3 pound signs in front of something, 4 pound signs in front of something, 5 in front of something, and you can see how big they are. Okay. So this is for 3 pound signs. I think this one up here is also a 3 pound sign thing. 4 pound size gets a little smaller, 5 gets a little smaller. So hopefully that makes sense to just, change font size very easily, and it also makes them kind of stand out. Okay. But of course, there's also a way to change font size manually. But then, of course, as always, anything that seems simple takes more work in Markdown. Hopefully that makes sense. So if you want to change the font size, unlike just clicking a button on Microsoft Word, right, you have to type these little hypertext commands. H2, H3, 4, 5. These are different font size commands. Okay, and you can see which one gets bigger and smaller. Okay, so 2 is it's the biggest one. There's no H1 for some reason. Okay, and then 3, 4, 5, 6. You can. I think there's no 7 either. So I think this is as small as it gets. Okay. You can also change the font color, and of course, this is also a complicated command. To change the font color, you have to do this alligator span style equal color.blue, and this actually has like a lot of functionality. You can change like the font type, and to be honest, in your notebook, you're just reading this for yourself, right? If you really want to do that yourself. You can put in a lot of stuff here, so you can change the color, the font style, type out Chinese characters if you want. But in this case, you're just changing the color, so you can. You also have to end this. So whenever you start something, you have to end it, because otherwise it'll make your entire document blue. Okay, if you don't end it. Okay. So example. So this is the little code, right? If you want to make this text come out blue, right? You start with blue, you end the blue, and then if you want to make this text red, start with red, you end it with red. That way you can actually change the colors of things. Okay. I'm not sure how often you will use this, but it's just so that you will think this is pretty easy to do, but just like typing up. A lot of times what happens is just you end up copying and pasting this anyway, so hopefully it's not too bad. Okay. You can also italicize stuff and bold stuff, and this makes no sense either. To make something italic, you put underscore around it. Why? I don't know. To make something bold, you put 2 stars around it. Okay. Right. I think if you just Google search, Markdown cheat sheet, you'll probably find a PDF that basically tells you like all these coding stuff, how to do all this stuff. Okay. So it'll be useful, to just have on a tab or something like that. But yeah, none of this. Someone at some point said, "Well, I want to italicize something on Markdown. Well, that underscore character is not used for something right now. I'm going to use it." Okay. I think that's the big reason. All right. What's really cool about Markdown is it can make lists, because this is going to be super useful when you guys are doing your lab. Because a lot of times, instead of writing things in paragraph, it's easier to just kind of type things out in lists. Okay. This is actually very nice and easy to use. I don't know why it's kind of blurry like this. Okay. Right. So to make a list with just bullets, you just put a star in front of it. Make sure to put a space. If you don't put a space, it'll just type star item instead. So star with a little space, you can make a little item. Okay. You can also make sublists by basically typing out your normal list and then going back to the front and tabbing it over. Okay. By default, Jupyter Notebook uses 4 spaces. You can type 4 spaces if you want, but if you type tab, it'll do the same thing for you. Okay. So let me just show you what this looks like. Right. So you can have, this used to be a star, right? This used to be a star, and then you can This is interesting. What happened here? Ah, I didn't do the double return, of course. Right. So now it looks correct. Okay. Right. You can also make sublists by star. You know, this used to be a star, right? This used to be a star with an extra tab on it, right? So this is a circle now. This is a dot. If you keep doing this, it will make different shapes for you, right? Okay. You can also number things, and it does this automatically. It's really annoying, actually. You can only make number lists with numbers, right? You can only make number / character lists with numbers, okay? So you may think, oh, this will be one, you know, I type 1 dot, item 1, 2 dot, item 1, C dot, item 3. I didn't do that. Let me see what, let me show you what I actually coded, okay? 1, 2, 3, 4. So basically changed the 3 into a C. I think it changed the 4 into some other letter. I don't remember what it was actually. Okay. So be a little careful about these number listings. Okay. So, but that's the same way you can make sublists by just tabbing over one more time. Okay. But it only works with stars and it only works with numbers. If I type in, you know, A, B, C, D, E here, it doesn't work. You know? Okay. What's really neat is that you can type equations using LaTeX style equation editing coding. Will be useful is because next week we're going to be learning how to write our report on LaTeX anyway. So you're learning this in Markdown. LaTeX will be the same. 99% the same. Okay, it's not exactly the same. Sure. LaTeX is the original. Basically, Markdown adopted most of the technology, but not all of it. Okay. So for example here, right, in order to type an equation, you put $2 signs around your equations. Okay, and now you are in equation mode. Equation mode. Okay, and these are special commands in equation mode that does things that are different than everything else. Okay, so for example, f_g, what will happen is that it'll basically put a g subscript underneath the f, right? And if you want to make a fraction, right, a fraction is actually /frac. And then you have to also use these curly braces on the numerator and the denominator, okay? And then these carets will give you superscripts instead, okay? So you can have, okay, one thing to note is that if you only have one character to subscript or superscript, you can just type that character. If you have more than one, for example, F elect, the electric force, right? You actually have to put a little curly brace so that includes everything, because if you without that, it'll just underscore the E, and then the LEC will just be a regular print. Okay. Right. Just show you what this looks like, right? So you can type nice equation, and this is expected. Okay. Don't be typing some funky equation that I can't understand in just regular fonts. Okay. Okay. All right. So basically, the Markdown is a mini version of the full LaTeX math expressions. So there's a link not to overleaf. Where did I type that? Overleaf. There's a little tutorial on overleaf of math expressions. Okay. And this actually kind of brings up a neat thing. You can put links, okay, in your Markdown. Okay. You guys see what I just did? Right? Go up here, right? If you want to put a link to something, so let's say you have a document or a picture, actually pictures will automatically come up also. You can put the link in parentheses, okay? This is the link to this little mathematical expression tutorial from Overleaf, which is a LaTeX thing we'll learn about next week. But, right, you can put, and then on this side, around the square bracket, is basically what will show up on the screen. Okay, I can make this, alien, eggs or something like that, and it'll show up as alien eggs, but then the link will still be here. Okay, this is how you trick people into clicking links that they don't want to go to, right? Right. So, but Hopefully all of you guys have your cybersecurity training, right? So before you click on a link, you always look down here, right? Where it's really convenient to see what that link is actually taking you. Yeah. Okay. Anyway, okay. So that's a little lesson on Markdown, at least the text part. Any questions about this part? Sure. Everybody knows how to do everything now? All right. If you need a reference, like, yeah, just Google search, and then, there's like cheat sheets and stuff like that. Okay. All right. Another cool thing about Markdown is that you can put pictures in it, of course. Pictures is worth 1,000 words, and physics is worth more than 1,000 a lot of times. Okay. There are different ways to insert images. You can just copy and paste images into your Markdown. Be a little careful about that. What's actually happening when you copy and paste something? Let's say, I'm just going to take a little screenshot, right, of this little box here, right? And I can just paste this in here, right? This is just the text that will show up if the image doesn't show up. This is the funky file thing that's there. Where the heck is this? This is actually embedded into your Jupyter Notebook. If your Jupyter Notebook ever gets moved from one place to another, this funky file name is no longer valid. So whenever you're including an image and you're just copying and pasting it, if you were to move the notebook from one place to another, let's say you send it to someone else to look at your code, that's no longer going to work. Okay. In this case, it works because I'm running it on the same machine that I'm running it on. Okay. So if you want to make sure your image doesn't get delinked, what's that called in internet language? Out of sync, whatever it's called. Doesn't get a broken link. That's what it's called, right? What you can do is basically either A, right, put the image source, use the image source method instead. See here, right? These are two different ways to put in an image. The image source, right? The source could be a website, right? Okay, this can be anything. Okay, or it can be something on your local drive. Okay, so whenever you're sending this notebook to someone, you also have to send this picture over. Okay, what's really cool about image source as opposed to this pasting thing, the pasting thing gives you no option to change the size of the image. This one you can. I can make this bigger, smaller, whatever size I want. If I want this picture to be super, well, let's make it small. Right? I can make the width 30 pixels wide. Hopefully you can still see it, right? All right. I can make it big again, right, by changing the size, right? And that way you can change the size of images. Okay. You can either link internet images or local images. And this is actually a much better way than copy and pasting. Copy and pasting is very convenient, but it gets broken all the time. Okay. So whenever I see one of my notebooks and it has broken images, because I was lazy and I did a copy and paste. Okay. All right. And this is going to be useful. So I forgot to mention. So like whenever you read something in the lab manual, you can just do a little clipboard. You can copy and paste that over, right? Sorry, copy, save it, and then put in the image source. Another thing is that if you did a calculation or did a drawing on a piece of paper, you can take a picture of it, right? You can load that image in there also, right? So that way you're not, forced to type. If you're doing like 20 lines of algebra, right? It's really hard to type that stuff in, right? So having the ability to basically insert images is really nice. The other thing you're going to be expected to be able to insert are tables. So you can make tables. Actually, I'm going to do it the easy way first. Okay. You can just copy and paste it in. This is probably an okay method. Okay. So what happens is that if you were to open Excel, for example, I don't think this works on what is it called? Google Sheets, right? If you have a bunch of numbers, okay. I think that's enough numbers. Well, technically, wet is not numbers, but okay. You can actually paste that into your what's it called? Markdown. And for whatever reason, on my computer at least, it does it 3 times. So I don't want it 3 times. So I'm just going to delete the other 2 copies of it. Okay. And then if you do a Shift Enter, it'll actually put that table into your notebook as an image. It's no longer a number. Okay. Right. The harder way, and the thing is, what's going to happen is that if you're taking data manually while you're doing the lab, you might as well do this because you can enter in the numbers one at a time anyway, right? Okay. And this is the making a table, what I call the bar methods, okay, using bars, okay? These are little bars, and this is how basically LaTeX and Markdown interprets how to figure out how to make tables, okay? So between 2 bars are the stuff that's in your table. So the month is between these 2 bars, savings / dollar. Remember why did I put a slash here? Yeah, it doesn't change the equation though, right? This is an escape character, right? So $sign is a special character. I want to despecialize it, so I put a little slash in front of it. Okay, so this will just type savings $sign there, right? Okay, and as you go down each of them, you don't have to line it up like this, but it's actually nice to have it lined up like this. Notice that I actually push this out a little further. Okay, you can start typing the items in your table. Okay, and the numbers, you can type whatever you want in it, right? Okay, and I also want to show you this little these little dots. Each of the dots, each of the dash is it's like the minus sign on your computer, right? Represents a space. Okay, so the more minus sign you put, the wider the table gets, and the little colon here tells you which way should the text be lined up. So this is actually lining up to the left. If I put the colon on this side, the text will line up to the right. So it's all, if you want to make your table nice and pretty, okay. And then you can also put a caption on the table. Okay, and let's see what this looks like. Okay, so you can see, oops, the table's over here. Okay, made it pretty wide for some reason. You have your first column, your second column, and then you have the caption for the table underneath. Yeah.
Is there a way to center your columns rather than left or right justify?
Yeah, I think there's a command for that. I think by default it's left justify, and I think there's a forgot what the thing is. It's probably on this cheat sheet. Okay. Guess it's not on this cheat sheet. Okay, the way you figure it out, Markdown, tables, center, column. Oh, you put the two dots, the 2 colons on both sides. Okay. All right. What was I going to do? Where was I? Okay, good question. Okay. So if you're just taking data during the lab, just do this, right? But if you have a bunch of stuff on an Excel spreadsheet, don't bother retyping everything. Just copy and paste. Okay. Okay. So I'm going to go through kind of an example, but I'm going to get a drink of water before I start that. It's going to take me maybe another 15 minutes to talk through this. So can we take like a 2-minute break? And then I'm going to pause the video recording. Okay. So let's record again. Okay. So what we're going to do the rest of the time today, hopefully maybe we'll be done in like 40 minutes or something like that. Okay. is to basically kind of get you guys started on a notebook yourself using the mass spectrometer labs. So those of you who are on your computer, the lab is actually posted, the lab manual is actually posted on Canvas under here, mass spectrometry. Okay. And then what you're expected is basically, kind of as an example, write the title and introduction to it. And then there'll be some additional markdown exercises. Hopefully they'll be quick. And then you just turn it in as an assignment for Wednesday. That way you have that document up and ready to do your analysis on and practice that on Wednesday also. Okay. So if you don't have your Canvas open your Canvas and then maybe open this document, just have it sitting on one of your tabs. I probably should do the same thing. All right, close, open a new screen. Okay. And this is a lab that's not going to be run this semester, I think, unless someone really, really wants to do it. It takes a little bit of care to run it, and it's just a little bit, it's very costly if a mistake happens. That's why we tend not to run it. But it's a mass spectrometry lab to basically measure different trace gases in the atmosphere. But this is just going to be a kind of a working example. That way you guys can play with it. Okay. So as I mentioned, right, the introduction, we're going to be writing this introduction today. Okay. And the idea is that, right, you want to introduce the science, right, of what you're doing in the lab, not what you're kind of like technical stuff yet. You kind of want to introduce the science background, right? So, abstract gas sampling can be used in many science applications, such as trace gas monitoring. If you want to figure out how much carbon dioxide is in this room right now, you can measure that. Analyze chemical reactions, chromatography, and even dark matter detection. Not directly, but basically I learned how to do mass spectrometry in my work when I was doing direct dark matter detection, because one of the gas we use is xenon, and we actually need to figure out what fraction of the xenon, which isotope it has. And by separating the different masses of xenon, you can actually figure that out. Okay. And one method of atmospheric gas sampling is done through mass spectrometry. And then whenever I write ... means this just kind of keeps going. Right? I don't want to bore you with all the text, right? Because this will probably be like 1 or 2 paragraph long. Don't make your introduction too long, but make it as long as you need it to be, right? Okay. So one thing is that for science writing, we don't try to say, oh, you have to write 500 words, otherwise you get an F, right? So you use as many words or as few words as you need in order to describe what the science is. And typically fewer is better, but then you run the risk of skipping something, right? But if you type out the entire, if you just download the entire Wikipedia and then dump it onto your notebook, well, first of all, you get a 0 for plagiarism. Second of all, no one's going to read it, right? If something's too long, people aren't going to read it, okay? And whatever doesn't get read doesn't get credit anyway, okay? And this is just an example, basically what I did is I did a little screen capture, right, of the schematic, right? So in the introduction, it's nice to have these pictures, schematics, something that ideally, right, you can give it to a non-science person, have them read it, and have them, understand, okay, I kind of get why you're doing this, okay? That's what the idea of the introduction is, okay? And hopefully, as you write this before you do the lab, okay? And you're gonna write one in your report after the lab, and you can contrast the difference of your own understanding before and after too, which is kind of neat. Okay?
Which one would we use for when we turn it in?
You turn in both. Yeah.
Just put a red number in?
Put a what?
Just make another.
Yeah, so this is the notebook is done in Jupyter Notebook. The report's going to be done in LaTeX, which is very different. Yeah, sure. Yeah, but you can reuse the same information here, right? But you're going to, hopefully at the end of the lab, you actually have a slightly different understanding what you see, right? Okay. And of course, you can do the procedure. So this is the equipment list. I think in this case, I think the equipment list is actually given to you. Where the heck is it? Yeah, is there an equipment list? Oh, there is no equipment list. Okay, great. So you have to type up your own equipment list. Okay, so the equipment list is not necessarily going to be like display on each of the lab, because each of the labs are written by different people at different time. So that's not gonna, there's no conformity with that. Okay, as you can tell, right, I made a little, so this is like a header, what, 3 pounds or 4 pounds? How many pounds did I get? Oh, so this is a 4-pound header. I made a little number list, right? The number list makes a number, right? And then, this part here is another, so each of the section is 3 number sign, right? Each of the sub part of each section is $4 pound signs, right? And that way you can delineate different levels of separation in each of your section. What happened to the thingy? Off the ability to compile. Okay, so usually when this crash, I think there's the connection between basically your Jupyter notebook that's running in your IPython functionality running in the background got disconnected from your browser. So hopefully if I close it and open it again, it'll work again. Of course, it starts off on the top again. Okay, there it is. Okay, all right. Okay, and then you basically, each subsection, right, pumping down, sampling the gases, right, they have different parts to it. As you can see in this, even in this notebook, right, I am using, right, the math functionality, right, whenever I have a number, right, that's not a simple number like 10, 20, 10 to the minus 9, that's a number that's going to require some special fonts, right? I put a little dollar sign around it, and then I'm able to put this to be 10 to the minus 9, and then define all of the acronyms. So ATM, atmospheric pressure, right? Don't assume that just because you did the lab and you know what you're doing, don't assume that anyone else will, okay? And when you're doing these procedures, right, I think if you want to write it in paragraph form, feel free to do so. But a lot of times, it's just nice to just do a list, right? Check this, turn on this, next step, next step, next step, next step, next step, next step, okay, until you get to the data, right? Okay. And when you do collect data, and I just want to show you this as an example, right? So, in this particular lab, you're using a little cylinder in order to collect the gases, right? And you want to figure out how big of a volume of gas you're collecting, right? That's not given to you. You can measure this, right, by, right, basically measuring the inner diameter, acronym ID, and the height of the cylinder. How would that allow you to figure out the volume of the cylinder? If you have a cylinder, what will be the calculation to figure that out? If I know this diameter and know this height, yeah.
Is it 2 pi r cubed?
Pi r cubed. 2 pi r cubed. 2 pi cubed. I think if you want a volume of a sphere, it's 4 pi r cubed. Pretty close. It's that right dimension, right? Yeah, it has something to do with R. R is this, right? But R is not ID, right? It's not the diameter. What is it? Pi r squared. Right. So basically the height of this, right, times, yeah, there's always a pi. Whenever you see a circle, there's always a pi involved. Okay. Just like that. Okay. But then, yeah, R is not ID, so it's actually ID divided by 2, right? And then square that. Okay. So that's the equation you're using. And since this is a conceptual thing, you put this in the Markdown, right? So once you measure your internal height, okay, right? Why is it displaying? It looks nice on my computer, but it looks crappy on here. the internal height, and then you record this to be 4 centimeters, and this is plus minus 0.1 centimeter. Why is it 0.1 centimeter? That's the uncertainty on my little rule. Well, it's probably not going to be this big old meter stick, but the rule also has the uncertainty of 0.1 centimeters. And we're going to dedicate more time on like how to quantify these things towards after the, maybe even before the analysis next time. Okay, and then the inner diameter is this. So this is the equation we kind of wrote down on the right-hand side, right? And then you basically write down what the answer is, and then plus or minus whatever the uncertainty you're going to calculate together is, okay? And I'll show you guys how to do this in the analysis portion, okay? Right? So this is all written in this little equation form, right? So whenever you have an equation in your notebook, it's also expected for it to be in equation form. Don't type stuff like this without the dollar signs. It doesn't make sense, right? It's very difficult for someone to read, okay? So the easier you make your writing to read, the more people will read it, the more they would absorb, right? And then, you know, and if you, not just in this class, but in the future, whatever you do, right? No matter if you're working or writing grants or, you know, doing reports for anything, the better, basically, you get a better grade or funded or, you know, get a promotion, raise salary, right? Easier for people to read things, the better it is for you, actually, okay? It's a selfish thing, right? Okay, so another example of this is that while you're collecting data for each of the gas sample, right, this is the way you would, you know, write, okay, where is this data stored? Okay, so this data is stored in Wayne's Crazy Drive, and then this is the file name. It's long. Okay, these file names are meant to be descriptive. This is one thing that I want you guys to get used to. You know, when you're collecting data, don't put data.txt. Okay, so that's going to be really hard for you're making it hard for yourself. Okay, so basically the way I want you to label your data files is that the lab, this class, whichever lab it is, you know, mass spec is probably enough in order for you to understand that. Who did the lab? Okay, because you're gonna, so everyone's name, okay, or at least one of your names, okay, and then what kind of data it is, and when you collected the data. Dates are very useful. Okay, do not count on the timestamps on your computer to keep track of the date, because every time you modify that file, it's going to change that timestamp. Okay, label it yourself. Okay, okay. Don't count on the computer. Count on the humans to keep track of things. Okay. And the result discussion. So this is a place where you find like a big giant table like this. Okay. So I think I did this. I did this manually, but I just copy and pasted a lot of the values. So, you know, this is a way to make a bigger table. So just more bars. More bars means more tables, right? Okay. When you're making tables, also make sure to label your units very clearly on the top. You don't have to put the units on every row, right? So this is a oxygen percentage, nitrogen percentage, but then carbon dioxide is measured in parts per million, and so is argon, so that's a different thing. Yeah.
The file name, you put the data Sp25, so it's not day, year, or date.
However it is for you to figure it out. Actually, what I like to do is actually year, month, date, day, because it just makes more sense to me. Because if you were to put this in Europe, if this file was sent to someone in Europe, they would think it's March 2nd instead of February 3rd, right? So yeah, I probably would have done 2025 0203, okay? Right. But unfortunately, you know, US is always a special character, okay? Okay. So in this discussion, this is going to be something that's going to be very important for you to start looking at the data, right, as you do the analysis, and discuss whether or not this makes physical sense. Okay. And so remember, right, if a data point doesn't make sense, you have multiple options, right? You can go back and take the data point again, right? B, right, you can try to explain it away, right? Or C, if you completely ignore it, you will just, lose points because of that, okay? You'll just take the hit, right? Those are your three options, okay? All right, as I promised, we're going to do a little bit of exercise. So let's try to get started as a little demonstration, let's say. Okay, let's open this mass spectrometry PDF file, which is on Canvas. Okay, and then what we want to do is actually basically start making a pretend notebook for it. Right? Okay, so start your writing the title and read the lab manual, at least the introduction part of it, and then maybe start typing the introduction section, and that way I can come around and help you guys, okay? All right, and then before I end up while I still have all your attention, so what I want you guys to do before Wednesday, okay, is to basically turn in that starting notebook plus a few exercises. Hopefully it's not going to take too long for you to do. It's just, do some exercise on making paragraphs, making, bold versus light. So hopefully it won't take you more than 10, 15 minutes to do. Okay. You can even do it in here if you're done with the this introduction part. Okay. And I can be around to help you with that too. Right. And then you turn that in on Wednesday. And Wednesday, what we're going to do is we're going to start the data analysis part, where it's basically the middle part of this. Because right now, right, so far we only did the left-hand side. So on Wednesday, we're going to be chugging through this middle part. We probably won't get through the entire thing. We'll probably take 2 days for us to do this, but we'll be in the middle of this on Wednesday, okay? All right, so